we would like to take Green's theorem and we would like to generalize it to other planes. So here is the xy plane, here is the domain, and its boundary is like this. The path moves along the first axis, and that gives us the derivative of the second component of the vector with respect to the first axis. And the path is in the opposite direction to the direction of the y-axis, the second axis. And so we get minus the derivative with respect to y of the first component of the vector field. That's what goes into Green's theorem. Now we'd like to see what happens if we actually think about the yz plane. And so here's the way we should think about it, or we'd like to. Let's take this and rotate it like that until we have the first axis along the y direction and the second axis along the z direction. And again, we have the path going along the first axis and opposite the second axis. Let's go back to the first situation and rotate it the other way so that this plane becomes the xz plane. So if we rotate it this way, then this becomes the z-axis. That's the first axis. And this becomes the x-axis. That's the second axis. And again, the path moves along the first axis and opposite the second axis. Here's a summary of what we've found in taking Green's theorem from the xy plane and putting it in the yz plane or the zx plane. In the xy plane, x is the first variable, then the derivative is of the component along the y direction with respect to x, minus the component along the x direction with respect to y. In the yz plane, y is the first variable, and so we get the derivative of the component along z with respect to y, minus the derivative of the component along y with respect to z. In the xz plane, z is the first variable, and so we get the derivative of the component along x with respect to z, minus the derivative of the component along z with respect to x. And so this is taking the two-dimensional Green's theorem and looking at what it means when we look at the other coordinate planes. It's exactly the same theorem, the same calculation.